Here in this video, we'll see a problem on pentagonal plate. The question is, a pentagonal plate of 30 mm side has one of its sides in VP. The corner opposite to this side contained by HP is 20 mm in front of VP. Draw the projections and find the inclination of the surface with VP. So this is the question in front of us. Here I'll quickly explain the initial conditions. For that, here I'll draw an XY line. It is given pentagonal plate of 30 mm side has one of its sides is in VP. So if the side is in VP, it means the entire pentagon is in VP, and that side we have to take it on left side because in case of planes, the left hand side is the reference. Thirty mm side, measuring 72 degree from a single point here, 72 on the other side. Next, after measuring 72 degree on both sides, I'll measure this side which is 30 mm, cutting this line, even from the other side. From here, I'll draw a light arc. Joining all these points in proper sequence. Giving the notations here. So this is the front view in which we are seeing the pentagon. I'll make it dark. So this is the front view. Next, for the top view, this pentagonal plate, since the plane or a plate, they don't have any thickness, the thickness is negligible, so it will appear as a line in the top view. A comma B, here we have C comma E, this is point D. So this is the plane. The next condition is the corner opposite to this side. Which side? Side A dash B dash on which it is resting. So the corner opposite to it is D dash. Now contained by HP is 20 mm in front of VP. So in the next condition it is given that this point D, which will be in HP, is 20 mm in front of VP. Now 20 mm in front of VP will be visible in HP. It means here in this problem, the inclination of the pentagonal plate is not given, but they have given that point D is 20 mm in front of VP, that will be in HP. For that, I'll draw a light vertical line marking 20 mm over it. Projecting a light line. Next, here I can see that in case of this plane, it will be fixed at A dash B dash. That side is fixed. And picking up this point D dash, I am going to tilt this pentagonal plane. So when I would be tilting, the shape gets changed. That we have to draw here. For that, first I'll mark a point as AB, which is a fixed edge. Then I'll measure the length of the cutting plane from AB up to D, keeping it over here. Draw an arc cutting this line which is at 20 mm distance so that I get the length of the plane. Next, from AB up to CE, The distance of point D, it was given 20 mm in front of VP, so it is seen in HP. I'll give the dimension to it. So this is the top view, and here the inclination, I'll say it is with respect to VP seen in HP, denoted by phi. Next, I'll project the front view. For that, starting with AB, they are onto the same location. Then point A dash. So where A and A dash they intersect, that will give me the point A dash. On the same line there is point B as well, so B dash will be projected. Getting B dash. Then for C and E, projecting them upwards. So here projecting C and E, and from the front view getting C dash. So where they intersect, here I'll get the point C dash. On the same location there is point E as well, so for that I need to bring E dash here. Next, for point D, here we have point D dash. Next, joining them in order. So here is the front view and this is the top view of this pentagonal plate, which is 20 mm in front of VP seen in HP, that is point D. Next, I'll have to measure the angle here, this angle phi, which is not given. It comes out to be 25 degree. So I'll write down, therefore the inclination of the surface with VP is phi is equal to 25 degree. Then here I'll give the dimensions. Thirty mm side, this is the true shape and here is the apparent shape. And with this the problem gets completed.